In this video we are going to study how can we identify the element which is going to oxidize or reduce. Here I am going to tell you the tricks which you can use to identify easily for the element which is going to oxidize or reduce. So start. Here I am writing hydrogen, electron and oxygen because redox reaction are carrying out through three steps. Number one, through hydrogen, number two, through electron, and number three, through oxygen. For this purpose you can write here oxidation, OXID for oxidation and RED for reduction. In order to memorize these tricks, you can write here plus above oxygen in case of oxidation. It means that if an element absorbs oxygen, in other words, if oxygen is added to an element, then the element undergo oxidation. That means, for example, if CH4 is burnt in the presence of oxygen, it forms carbon dioxide and water. You can easily identify that carbon is undergoing oxidation. According to above formula, oxygen is added to this carbon, so carbon is oxidized to CO2. Next, if an electron is, E stands for electron, if an electron is removed from an element, simply let's consider an example of sodium metal. If sodium metal loses one electron, it gains one positive charge. According to the definition, if sodium loses one electron, it oxidizes to Na positive ion. Third one, through hydrogen. If an element loses hydrogen atom, that means hydrogen is removed from any element, any molecule, from not an element, from a compound or from molecule, then the molecule undergo oxidation. In this example, you can see hydrogen is removed from this methane. This equation shows that methane gas is oxidizes to CO2, carbon dioxide. In other words, we already checked through oxygen that this methane is oxidizes to CO2 because hydrogen is removed and oxygen is added. In next step, we focus on reduction reactions. Reduction is reverse to oxidation. In first step, we will focus on oxygen. In oxidation, we check that if oxygen is added to an element, then the element is undergo oxidation. Opposite to oxidation, if oxygen is removed from any element, any compound, then the element or compound will be undergo reduction. The compound element will be reduced. For example, For example, Fe2O3. Iron oxide is reacted with carbon monoxide. This reaction is taken place in a furnace when the purification is needed for iron oxide. When you are trying to purify iron oxide, which is obtained from iron ore, it is heated in the furnace with carbon monoxide. As a result of this reaction, iron is obtained with the gas which will carbon dioxide. So if you focus on this reaction, oxygen will shift to carbon monoxide, results in the formation of pure iron having no oxygen and carbon oxide. The oxygen which is removed from this iron ore shift towards the carbon monoxide, results in the formation of carbon dioxide. So if oxygen is removed from any compound, any metal, any element, then the element, compound or molecule undergo reduction. Second one, if an electron is added to, opposite to oxidation. Oxidation consider removing of electron, but reduction considering to addition of electron. If an element gain, if an element or ion, let's say we have sodium ion, undergo reduction, that means sodium will gain an electron. If sodium gain an electron, then sodium will reduced. Sodium ion will reduce to sodium 0. In this case, you will see that the oxidation number, the apparent charge 1 positive, will shift it to 0. It means oxidation number reduces. Okay, oxidation number reduced, higher to lower value, +1 to 0. Last one, if an hydrogen atom is added to any molecule, then the molecule undergo reduction. So next example for hydrogen. So if we consider ethene molecule and we add hydrogen molecule in this reactant species, that is ethene, then this molecule will go to CH3, single bond CH3, that will be ethane. That means ethene is reduced to ethane, that is oil, that is ghee. That means double bond absorb this H2 molecule and convert it to ethane. If we added H2 molecule to double bond or any molecule, as a result of this addition of H2 hydrogen gas, then the reactant species will be reduced. So that is the lecture of today. I hope you will understand and learn from this lecture. Thank you so much. Have a nice day.